Hello everyone, so in today's video we are going to look at systems of linear equations, whereby a linear equation is an algebraic expression of the form y equals mx plus b, whereby the m is the gradient and the b is the y intersection. And also it can be written in the standard form of ax plus by being the same as z, whereby a and b are the coefficients. These coefficients can form what you call an augmented matrix from a system of linear equations, like we are going to see down here. And also when we talk of a system of linear equation, it is simply a collection of two or more linear equations that involve the use of same variables. These systems of linear equations can be solved using different methods, whereby in this video we are going to look at Gaussian elimination, and this method here involves the use of row operations to transform an augmented matrix into the upper triangle form. So let's have an example and see how this works. In our example here, we have a poverty eradication program that invests in 3 interventions, which are these ones: the micro loan packages, the skilling training cohorts, and the agriculture input kits. Then we have the planning team that goes ahead and makes these assumptions, whereby each micro loan costs 0.8 million, the training cohort is 0.2 million, and then the agriculture input kit is 0.1 million. And each micro loan helps on 3 households, training helps 2 households, and then the input kit helps 1 household. And then the project is targets actually 800 households, and then the implementation team can handle at most 350 combined micro loans and trainings in this quarter here. So these constraints actually, they are very important because they help us to derive equations. And then so in our linear equations we are going to equate them. Like now here we have a total of 100 millions, we have here a target of 800 households, and we have here 350. So these are going to be the equivalency of our linear equations. Now part A of the question tells us to define these variables and then formulate a 3 linear equations system from the program. So from those we can simply formulate these equations here. 0.8 million plus 0.2 million plus 0.1 million being equivalent to a total of 100 millions. So I simplified this further by multiplying through with a 10 throughout, and then I ended up having this. And then the second equation here was also got from the second constraint here of the households, which the target was 800 households. And then the last one, the micro loans plus this the trainings, will at most give this 350. That's where we get our third equations. So part B of the question told us to solve this using Gaussian elimination, whereby I told you with the Gaussian elimination we first need to get the augmented matrix, which is this, simply the coefficients from the linear equations. And then from there we need to get this into a matrix with ones on the main diagonal. So by doing that, we can now see that since we have here 0, we swap these rows, the first row with the third row, such that we get rid of this 0 here, and this is what we did. And then we have here our ones. We can see that now when we solve, we can get ones on the main diagonal. So from there we go ahead and perform row operations. These are the row operations. We perform these until we get a matrix like this. You can clearly see that now we have ones on the main diagonal as expected. So from there we solve this for this, since now we have our 1A being equivalent to 60, we can go ahead and substitute in for the other values, and then we finally get this. What does this imply? This simply implies that when we allocate 40 microloans and then run 310 training cohorts and distribute 60 input kits, they will exactly lead to the 100 budget million that we have, and then it will meet the target of 800 households, and then it will respect the limits in the form that when you get 40 times 0.8, and then even this one with respect to this, when you multiply all of this, it will arrive to 100 million budget. And then with the households, when you multiply 40 times 3, then 310 times 2, then 60 times 1, it will give you 800 households. So that was it for this video. Thank you.